On the next page of our workbook, we're still in section 1.1, dealing with functions. We have a continuation of the example that we ended the last video with, which is namely, determine the domain. Okay, so we're going to determine the domain and declare if it's a function or not as we take a look at it. Now, once again, on E, depending on your level of function knowledge or previous math courses you've taken, you may be able to look at this and say, that is not a function. But if you want to see the algebra behind it or the graph behind it, show that it's not a function, the first thing we're going to have to do is get this y by itself. So I'm going to subtract x squared from both sides. I get y squared equals 9 minus x squared. Then I'm going to take the square root of y. We're going to get y equals plus or minus the square root of 9 minus x squared, which we can solve algebraically. If we want to graph it, y equals a positive 9 minus x squared or 9 minus x squared, and y equals a negative square root of 9 minus x squared. Now, if you wanted to graph that, you just second square root 9 minus x squared, and then on the second line, a negative square root of 9 minus x squared. And you can see right away it's not a function. If you drop a vertical line, it's not going to hit the function just once. It's going to hit it at least twice. So this is not a function from visual inspection. If you wanted to see why it was not a function algebraically, then what you would do is this part has to be non-negative. So we have 9 minus x squared is greater than or equal to 0. So negative x squared is greater than or equal to negative 9. And then we're going to divide by that negative. And if you remember on an inequality, when we divide by a negative, the inequality flips over. So x squared is now less than or equal to positive 9. And then we're going to take a square root of both sides. So when you take, and this is once again how far you've gotten in the previous math class, when you take a square root on an inequality, you end up with two numbers to represent what could be the x value for that square. So in this case, x squared is less than or equal to 9. We're looking for the x values that, when we square them, gives us less than or equal to 9. So on our number line, well, we already know 3, right? There's 3, and it's a dot because it's equal to. And then the other number that when we square it, we get 9 is negative 3. And we're looking for all of the x values that is smaller than that. So we're looking for this. Okay, so we would say the domain is from negative 3 to 3. Now, you may remember when you take the square root, you actually end up with negative 3 is less than or equal to x is less than or equal to 3. You may see it written that way as well. And all that means is this is between negative 3 and 3. Now, if we look at our graph, you may say, whoo, that's a mess. And we've got some open spots over here, and that's just the limitation of your calculator. The pixels are not showing up that graph. You can go to zoom, and you can square it, and it may look a little bit more familiar to you, because that was the equation of a circle with radius 3, that's centered at the origin. But you still may think there's some gaps there. And once again, the calculator has a very hard time drawing something here that's almost essentially vertical. It has a tough time with that. So your calculator can make it look like the negative 3 and the positive 3 are not included. But they are, because if I put a negative 3 right here, 9 minus a negative 3 squared is 9 minus 9, which gives us 0. And that's part of our domain. So the domain for E is from there to there. This one's going to involve, let me switch to some black ink. This one's going to involve a little bit of fancy factoring. And I'm going to once again do this algebraically just to remind you of how to do this. If we want to work this problem, we need to get y by itself. So I'm going to move negative xy over here. And you didn't have to move it to the right. Could have moved 2y to the left. But I just made a choice, and negative xy is going to the right. So I have negative x equals 2y plus 3 minus xy. And, oops, I'm going to move the 3, minus, over to the other side of the equation. And negative x minus 3 is equal to 2y minus xy. Now, what I'm doing is I'm trying to build a function that I can graph over here at the calculator. So to graph it on my calculator, y has to be by itself. So I'm going to factor a y out. So I have negative x minus 3 equals y times 2 minus x. So I just factor that y out of both of those. And then if I go up here, to get the y by itself, I need to divide completely by 2 minus x. So I end up with negative x minus 3 is equal to 2 minus x, or excuse me, I said that wrong. Negative x minus 3 over 2 minus x is equal to y. And that's what I can put into my calculator. So y equals, I'm going to go to, I hit alpha, then y equals, and it gives me my fraction. I'm going to have negative x minus 3 in the numerator, and then 2 minus x in the denominator, and hit round. And look at that beautiful thing. That means we have some issues right here. And you may recall that is a vertical asymptote. The vertical asymptote comes from the denominator. Because if you remember, you cannot divide by 0. And if we take a look at this denominator, there's clearly a number that if I plug it in, I'm going to get 0. So to solve this algebraically, we take the denominator and we say 2 minus x cannot be equal to 0. And we move the x over, so 2 cannot equal x. So my domain is all of the numbers from negative infinity to 2, parentheses, union, putting them together. Then we're going to pick up on the other side of 2, positive infinity. And because we use these parentheses, what we're saying is the domain is every x value except 2. And you can see it over here on the graph, right there. There's that vertical line, cannot exist. Also, you can also go to your table on your calculator, the second graph, and you see right here at 2, it says error. That means we've got a problem with our domain at that point. All right. Now, further down the page, we need to consider this parabola, x squared minus 3x plus 5. We need to find the domain, and then we need to do some function notation. So, let's take a look at this function. We have x squared minus 3x plus 5 on graph. And it's a beautiful little parabola, as I said. It's considered, it just keeps graphing up here. So the domain is all real numbers, negative infinity to positive infinity. Or you could say all real numbers. I've seen domain written that way as well. Although our homework and our tests tend to use this notation. And then the next thing we're asked to do is to substitute in these values for x. So this function notation, f of negative 2, tells me that my x value is going to be negative 2 for this function of f. So f of negative 2, I'm going to take a negative 2 and put it into each of these x's. I have negative 2 squared minus 3 times negative 2 plus 5. Please, for your sake, every time you substitute something in, put it in parentheses. There will be times when order of operations will get you if you do not put it into parentheses. So go ahead and put it in this way, and negative 2 squared is 4. Negative 3 times negative 2 is positive 6, plus 5 gives me 15. So I would say when x is negative 2, y is 15. And we can see that if we go over here to our calculator and hit second table, and we hit the up cursor, you can see when x is -2, y is 15. All right, so the next two function evaluations, one of them involves putting another function into f of x, another function of x, and then the next one involves putting in an expression. So f of 3x says that everywhere there's an x, I'm going to put a 3x. So I have 3x squared minus 3 times 3x plus 5. And I get 3 squared is 9 times x squared. Minus 3 times 3 is not -9 times x plus 5. So there's that answer. And then f of a minus 1. I'm going to put a minus 1 in x squared minus 3 times a minus 1 plus 5. And then I'm going to take the opportunity to remind you that when you have a binomial, something like this, a minus 1, and you square it, it is not equal to a squared minus 1. Because a minus 1 quantity squared means a minus 1 times a minus 1. And that means that we're going to have a times a is a squared, -1 times a is -a times -1 is -a, -1 times -1 is 1. So we're going to have a squared minus 2a plus 1. Okay, so just remember that when you square something like this, you have to do that distributive property, or sometimes it's called FOIL, F-O-I-L, to figure out the trinomial that comes from this expansion. So a minus 1 squared is this, and then I'm just going to keep following this down. We have -3 times a is -3a, -3 times -1 is +3 plus 5. And I'm just going to take all of this and kind of bring it down here. And combining like terms, I get a squared minus 5a plus 1 plus 3 plus 5 is 9. There's the answer to that. Okay, one last problem on this page. We're going to take a look at this function, and we're going to find the domain, and we're going to evaluate it. So we've already kind of looked at these. You notice this one right here. The denominator, this is a rational function. And in a rational function, the denominator cannot equal 0. So to find the domain, we start off by saying x squared minus 3x minus 4 cannot equal 0. Now, some of us are very good with factoring, and this is not going to be a problem for us. We look at x squared minus 3x minus 4, and we already know what that's going to be. Others, not so much. Factoring is not something you ever endeavored to internalize. So in that case, you can use your calculator, and what this is called is finding a 0. We're trying to find the x values that when I plug it into this expression, it does not equal 0. Or usually we're trying to find it equal to 0, but I digress. The way to make this work, we plug this in, and I'm going to head and hit graph. And where it hits the x-axis is known as its 0. The place that the function, the y value of a function equals 0. And you can tell by inspection what those two places are. This is -1, this is -4. So x cannot equal -1, and +4. I think I said -4, I apologize. -1 and +4. Now, if you want to factor this, the factors of x squared are x and x. We're looking for the factors of 4 that subtract to a -3. So we're looking at the factors of 4 that have opposite signs. -4 and +1. And when you have -4x plus 1x, we get a -3x. And then if you remember, we take this product and we separate the product. into these two equations, and then we solve for 4 and -1. So the domain is everything but these two numbers. Now if we put that on a number line, -1 and 4, we have circles here because it cannot be those two numbers. That divides by 0. But it can be every other number besides those two. So there's my number line picture, which means my domain is from -infinity to -1. That's this part right here. And then we're going to stick it together with this part from -1 to 4. And then we're going to place it with this part, which is 4 to infinity. And that's my domain. I have 3 regions on the graph. Now all I did over here was I put in this guy, because I knew that he could not equal 0. So if I could find where the y values equal 0, I'm golden. If you want to put the whole function in, you'll see these asymptotes happening at -1 and 4. So let me do that. Alpha y equals, I'm going to have x minus 2 in the numerator, and x squared minus 3x minus 4 in the denominator, and we'll hit out, and there's those vertical asymptotes. It's a little bit harder to identify those asymptotes because of the way this curves, but if you're really good at visualization, you can see that vertical asymptote happening at -1, and then coming down this way, going right through that -4. Oh, excuse me, +4. So there's my domain. All right, now the function evaluation, f of 3, means everywhere there's an x, plug a 3 in. Cannot emphasize enough, please use parentheses. So we have 1 in the numerator over 9 minus 9 minus 4. So we get -1/4. All right. Let's take a look at example 10. And then we'll end the video with example 10 and pick up on the next one with example 11. So in example 10, we're to consider these functions and we're to compute this expression. So this is when we're taking values and plugging into two separate functions, getting the y values from those substitutions, and then adding the y values together. So to start off with, f of 1. F of 1 is equal to 1 squared. 1 is 3 times 1 plus 7. So it's 1 minus 3 plus 7, which is going to be 5. So right here on this expression, f of 1 is equal to 5 plus. All right, now I'm going to have 2 times g of 3. Let me go find g of 3. G of 3 equals the square root of 3 times 3 plus 7, which is the square root of 9 plus 7, square root of 16. So g of 3 is technically plus or minus 4. But since I have just the positive part right here, we're just going to take the positive root. So the square root of 16 is 4. So I'm going to go back over here, and I'm going to say g of 3 is equal to 4. So now 5 plus 2 times 4. Don't add these two. Remember order of operations. Multiply first. 2 times 4 is 8. And 5 plus 8 is 13. And that's our answer.